We're going to visualize flow using a stream of fluorescein dye, which fluoresces bright green under an ultraviolet light. Here we're injecting dye from a small tube positioned just upstream. You can clearly see the streamlines as the fluid flows around the large tube. You can also visualize the quite complex flows that result. Here we're dealing with Reynolds numbers up around 15,000 or so, which is the range where turbulent flows are quite common. Let's now look at these flows a bit more closely. Turbulent flow around the cylinder has three major components. At the cylinder's leading edge, there is a zone of relative stagnation as the upstream flow encounters the cylinder and is temporarily brought to rest there. As the water flows around the cylinder's lateral surface, the flow is laminar and smooth. Finally, just behind the cylinder's lateral face is a so-called zone of separation, where turbulent vortices are generated as the laminar flow just upstream separates from the cylinder as parcels of fluid in rotational motion. The separation occurs in part because the fluid behind the cylinder's trailing edge actually is moving in the opposite direction to the prevailing flow. When this retrograde flow encounters the prevailing flow, this imparts the rotational motion to the fluid, which separates as a vortex. The retrograde flow also produces a zone of relative stagnation behind the cylinder, seen in the accumulation of dye there.